Welcome back. This is our second video in our series of demonstrations of the actuator, the first and only AI that is able to write complex, accurate software code. In the first video, we reviewed the properties of inverts and their attributes. We saw how small invert structures could represent some quite difficult concepts, all without needing any logical instructions. In this video, we're going to build an executable program with some simple file I/O. We'll also take a little look at sets as well as some statistical measures. Here's the file that we're going to read in. It's a delimited file in which we have squiggles as delimiters between each field. You can see that each record contains a piece of text representing a name, a number containing a salary, a date that represents a start date, and another number that represents a bonus percentage. So up here, we'll click on this button to create a template for our executable program. We are prompted for the type of executable. There are slightly different templates for certain specialized models, but in this case we'll just select a simple standard model. This will give us a structure filled with empty tabs. Every executable program will have a tab for runtime parameters and a tab for return data, but the main part of the program will be specified in the model tab, as well as all these tabs shown as A through Z. These tabs are where you build your invert structures for specifying what you want the program to do. You can rename any of the A through Z tabs, and indeed any of the inverts and attributes, in order to make your program more meaningful. We're going to be working here just on the main model tab. As you'll see, it is plenty big enough for our purposes and can be easily expanded with scroll bars to cover larger invert structures. Our program is going to read in a file, do a little manipulation, write something out to another file, and create a pop-up window to examine some intermediate information. So we'll start by specifying these. First, we need to create blank attribute sockets of the appropriate types. We'll have 3 file sockets and 2 diagnosis sockets. So now we'll describe our input and output files. We will need to specify the file names as well as the individual fields on each record. We'll start with the input file. We're prompted for the first field type. It's a text. So now click OK, and here is our invert. Next, we will specify the other field types using the plus button: number, plus, date, plus, and another number, plus. You can see these plus buttons enable us to make these inverts quite flexible. Finally, we'll type in the file name, which we've called employees.del. So now we'll do the output file. We're going to have the first field be a text file, a text field. So we selected delimit out. We're prompted for the first field. It's a text. And what we'll do is we'll copy across the person's name from the input file simply by setting a reference to it. We click on this, select the text file and right click, and there we go. Next, we're going to specify an amount field to represent that person's bonus amount. Now, for each person, the bonus amount will be equal to the product of their salary and their bonus rate. So for this value field, we're going to specify a product. Click here. It's a set. Here's the salary. Click, and here's the bonus rate. Now you'll notice that we have generic names for these buttons. These can easily be renamed to make them more meaningful. And finally, we're going to add a date field which represents an anniversary date from their start date but rolled forward to the end of the month. So here we have in the value, we're going to specify EOM, that's an end of month, and the target field for the end of month is going to be a date, and that date is going to be defined as the next anniversary of our start date. So we right click here and we're going to use 2024. We have to specify what the anniversary is. Just click on here and it's 2024 11/15. So we're going to be looking at anniversary from the end of November from the start date. And now finally we have to specify the person's name, the file name, which is output.del. Now one thing you'll notice is some small differences between the input and output fields. You can see here that with an output file, we have to specify the number of decimal places you want to capture. Otherwise, we won't know how to format that output field. So we've built it, we've executed it in no time at all. Let's see what we've got. We'll open that up. Open output.del, and there you can see the start date has been rolled around to the end of the following November. And you see the bonus, and then for the first person, the bonus of 1730 should be equal to 10% of the 17,300 from our input. There you go. Now, if our output file existed before, then by default, the actuator just simply adds new records. So if we run it again, to rebuild the program, run it again, we'll see that we've now just added some new records to output DEL. There they are there. So now let's go ahead and make a few changes. We're going to see how easy it is to modify an existing program using the actuator's invert builder tool. First, we're going to add a numeric output field. So we click on the plus button, there it is. It's going to contain double the salary if the salary exceeds 20,000 or half the salary otherwise. So first we're going to use an either or, and an either or allows us to place an alternative an invert that has alternative values into an attribute. And so here we need to specify a condition. Now the condition is we're going to take the salary field, and if it's larger than 20,000, then we're going to use double the salary. So we're going to take a product, put it in here. So if it's true, if the salary is greater than 20,000, we're going to put in the product of that salary times 2. So here's the salary right here. And here we just type in the number 2. If it's false, if the salary is less than 20,000, then we're going to use half the salary. So again, we take a reference to the salary here. And instead of a 2, we're going to put a 0.5 in here. So let's see what we've got. Click on that. We compile it, it's been built, we compile and execute it. And now we'll see in our output, you can see that for Jordan, we've got 8650, which you'll recognize as being 50% of the 17,300 we saw earlier. So let's make some changes now to the output text. Instead of just using the input file name, we're going to change the output name into all caps, and we're going to add the prefix senor. So we use a concatenate invert. Here we type in SR, and then the second field is going to be an uppercase right here, and when the target text for that uppercase is our input text. Quickly run it, let's see what we've got. It ran already, compiled, executed. Let's look at our output and scroll down, and there you can see Senor Jordan, Senor Pinter, and so on. So obviously this is necessarily a simple example, but you'll notice how quickly it was built and executed. So let's just shrink this a second and we'll look at some pop-ups now. We just right click this whole field, and there it is. The limit out is now shrunk. You can see we have plenty of space on our on our tab for a lot more material. So what we're going to do here is we're going to take an all-at-once diagnosis, and what this is a pop-up that allows you to summarize all in one place a set of information. So in our case, we're looking at 6 records, and we'll start off by specifying just the 6 salary fields. We just right-click this here. Here we go. Let's see what we get. It's already been built, and there's the salary fields. That's a pretty simple one, obviously. Let's clear this out, and we'll clear that out and we'll look at something else. You can see that this is a very powerful tool, obviously. Professional coders might make an analogy to print statements that they sprinkle throughout their code. But this is much, much better. For one thing, you don't need to figure out exactly where in the code to put it. Secondly, you don't even need to look at the code. So now we're going to delete this. Let's look at text just to see how easy this is to do. You right click it there. You click the run button. It's already been rebuilt, and there's the name. Let's just look at one last thing now. We'll clean this out. And this time, let's just look at the excess of people's salary over 15,000. We're going to use an excess in here. We're going to take the excess. And then here we type in hard code to 15,000. Let's have a look. Just takes a few seconds. It's already been built. We'll run it. Okay. And there's the number. And you can see the 2,300. That represents the excess of 17,300 over 15,000. An enormous amount of set manipulation is also possible. Let's take a little bit of a look at those. Here's a few set manipulation inverts. We'll look at a sorted set. We'll put that in here. We have to tell it that it's a number in this case. And we open that up. And now we're going to take the salary, make that the source set, and we'll sort it in reverse. Let's see what we get. So we're going to take all those 6 salaries. We're going to get them in order from largest to smallest. There you go. Let's do another one. So we'll delete this, clear it out, and we're going to look at all but the, not the largest 2. Let's do all but the smallest 2, shall we? Here we go. Not small n. That allows us to take a set and take all but the smallest n. So the set we're going to take is the salaries, and n will make that 2. So that's going to give us the largest 4 salaries. It's already been built. We run it. And there you go. So we 17,300, and I think there was a 20,000 that's been deleted also. So there you go. One other thing is you can chain together these set manipulations to make some very sophisticated constructs. Incidentally, you can see these red letter A's in our input fields. This indicates that these sets are all related, as you would imagine. Related sets can be manipulated together. For example, you might want to sort one of these related sets, just like we did, or perhaps take some subset, but you want this to drive the other related sets, perhaps to put them in an output file together. In a subsequent video, we'll show you how to manipulate these. It's a rich area, and we found a very clean and elegant solution to it. Let's take another look at a diagnostic that allows you to examine singletons. It's called Show Singles. We're going to put it here in the palette that we created earlier, and we're going to look at a couple of singletons that summarize the data that we've read in. Here's a simple sum of the salaries. We're going to the numbers directory, and we're going to look at some number inverts that deal with sets, some set measures, and the one we want is called sum++. We're going to insert that. And we're going to point to the number, which is the salary. Let's click this. Software has been built. Have a look. 145,800. That's the sum of the salaries. Now, we're now going to look at another statistical measure. Let's just delete this. We'll go down to the statistics library, and we're going to find just a simple mean. We'll put the mean in here. Just so you can easily check this yourself. We'll right click, put the salary in here, click, Well, the software has been built. Let's have a look. 24,300 is the average salary. And because we have the other all-at-once diagnostics still there, it's popping up too. There's no limit to what you can use this for, and there's no limits to how many of these diagnostics you can sprinkle into your model. We've asserted that the actuator is practically bulletproof, and this is how you can validate that every single component of a model is behaving as it should, from the inputs all the way through to the outputs. In addition to delimited files, we can also handle fixed position files. For these, we must specify the starting point of each field, and for text and numbers, we must specify the field length, along with the number of decimal places for any number. I've prepared this one ahead of time in a similar fashion to before. As you can see, you need to take a little care to make sure that the starting positions and lengths match the file layout. You'll see that we have two output files. One of these files writes a single record, and you can see that its value attributes require singleton data, in contrast to the set value attributes for the file out. So to sum up, we've shown you the basic components of a software program that can read and write to files, display values to the screen, and perform set manipulation. Based on what we've shown you in these first two demonstration videos, there is already an enormous variety of software that can be built in a very short time. It's worth reiterating that nowhere have we had to specify any of the instructions required to read and write files or to display pop-up screens or sorts or anything of that nature. All we've done is specify what we want and not how to do it. The actuator takes it from there. You can see how fast it is. Note also that there's no ambiguity in any of the inverts we've shown you. This is in sharp contrast to pseudocode and the kinds of prompts used with large language models. Not only is there no ambiguity in what you're asking for, you can easily validate what you get back using the diagnostic pop-ups. Every single step of the way. We've indeed entered a whole new world. I hope you found this useful and interesting. In the next video, we'll introduce inverts for specifying complex manipulation against large remote databases. They ensure full data integrity along with the highest levels of security. This allows you to build truly industrial strength applications. We'll see you then.